Hello everyone. Now let's start with the remaining section of the question 4, uh, the B part of the question 4. It talks about to draw box plots for both visualizing relationships, age and impact. And we have a box plot for that. Median age at 51 with a wide range is 23 to 21. Data is clustered towards the higher end, 50s and 60s, indicating a negative skew. Impact percentage box plot interpretation is median impact around 30.7 percentage. Most values fall between 26 percentage and 35 percentage, suggesting consistent impact assessment across complaints. Moving on to the C part of the question, draw a scatter plot and QQ plot to study the relationship. So as you can see, the graphs here, the scatter plot is done on age versus impact. A positive correlation is observed. Younger complainants, 20s, generally report lower impact, 10 to 20%, while older complainants, 50 plus, report higher impact, more than 30%. You can see that in the graph. Now, QQ plot gives us impact distribution, compares impact percentage distribution against a theoretical normal distribution. Significant deviations from the diagonal line suggest non-normal distribution, for example, bimodal or skewed. So you can see that in the graph itself. Now coming to part B of the internal one examination of data science, which is a similarity and dissimilarity in complaint profiles, uh, distance measures, and similarity search. Now coming to the question 1 of this part, which asks about briefly outline how to compute the dissimilarity between complaint profiles described by normal attributes, asymmetric binary attributes, numeric attributes, term frequency vectors. Now coming to normal attributes, method can be simple matching. Calculation would be difference equals 0 if values match, 1 if they don't. Formula would be d of I comma j equals in bracket p minus m uh, divided by p, where m is matches and p is total variables. For asymmetric binary attribute, context would be presence, which is 1, is more crucial than absence, which is 0. Method would be Jaccard dissimilarity. Formula is given by distance equals r plus s upon q plus r plus s. Matches of 0, comma 0 are ignored. Now coming to numerical attributes, method would be Euclidean, Manhattan, or Minkowski distance. Normalization can be done by ensuring essential to normalize values, for example, min, max, or z-score, to prevent larger values from dominating calculations. Coming to term frequency vectors, that is text. Um, Context would be comparing FIR narratives or text documents. Method would be cosine similarity, of course, converted to dissimilarity. Calculation can be done by measuring the angle between two actors. Cosine equal 1 for identical keyword distribution. Dissimilarity would be 1 minus cosine similarity. Now here comes the second question, which uh, gives us tuples or cases, uh, 22 by 1 by 42 by 10 and 20 by 20 comma 0 comma 36 comma 8, representing incident during duration. in minutes, witness present, exhibits evidence item count, alleged X count. Now it asks us to compute following distances among Euclidean distance, Manhattan distance, Minkowski distance with each equals 3, and at last supermum distance. So as you can see, the I have already repeated tuples A and B and the attributes associated with them. Now let us look on feature differences, which are duration 2, witness 1, evidence 6, x2. Euclidean distance L2 norm formula is, uh, sum of squared differences in square root, of course. Calculation would be in square root 2 square plus 1 square plus 6 square plus 2 square, which comes out to be square root of 45, and the results comes out to be 6.71. Now to calculate Manhattan distance, which is the sum of absolute differences, comes out to be 11. Now to compute Minkowski distance, which is the sum of absolute differences to the power h, uh, to the power 1 by h, the result comes out to be 6.15. Now for supremum distance, the formula is of course a max of absolute differences. Here it is max of 2 comma 1 comma 6 comma 2, and absolutely the result is 6. Largest single attribute is difference. Now coming to the third question, it asks about the median evidence impact score is often a robust indicator for triage, routing to fast track scrutiny versus detailed legal vetting. For massive complaint datasets, propose median approximation methods, GK quartile summaries, T-digest, reservoir sampling, analyze time-space complexity, and suggest heuristics to balance accuracy versus uh, efficiency. It's quite a long question. Uh, Now to propose median approximation methods and analyze time-space complexity, we have to go through GK quartiles, T-digest, reservoir sampling. So the GK quartiles are like maintains a data summary to answer quartile queries with guaranteed error bounds. T-digest is a clustering-based data structure, accurate at extremes and efficient for mediums, merging centroids dynamically. And reservoir sampling keeps a fixed size random sample from streaming data. The sample median provides an unbiased estimate of the true median. Coming to the question 4, which asks about a sample data set with two numeric features per complaint, scaled from NLP extraction. Given a new complaint query x equals 1.4 comma 1.6, rank existing complaints by similarity using Euclidean, Manhattan, supermum, and cosine similarity. Normalize each complaint vector to unit length and recompute Euclidean distances. Now, looking at the question, it is quite easy to compute similarity ranking. Uh, Rank complaints C1 to C5 by similarity using Euclidean distance. As you can see, the final ranking comes out to be C1, C4, C3, C5, and C2. Then the B part of this question, normalization. Unit vector normalization divide each component by the vector's magnitude. Example can be Curie X 1.4 comma 1.6 normalizes to approx 0.66 comma 0.75. Justification can be removes magnitude influence focusing on direction, ratio between attributes, making Euclidean distance similar to cosine similarity. Now looking at the B part uh, of the question 4, vector normalization and recomputed distances. Normalizing complaint vectors to unit length is crucial for robust similarity comparisons, especially when magnitude differences shouldn't dominate. This method is unit vector normalization. The process is each component of a vector is divided by the vector's magnitude, Euclidean distance. Uh, Example as given normalizes to approximately 0.66, comma 0.75. Why? Because it removes magnitude influence, focusing on the direction or ratio between attributes. This makes Euclidean distance of normalized vectors equivalent to cosine similarity. Recomputed Euclidean distances, which are normalized, after normalizing all complained um, uh, vectors to unit length, we recompute Euclidean distances from the normalized query. Uh, we do the procedure, and the new ranking comes out to be C1 oblique C3, which is a tie, comma C4, comma C2, comma C5. With this, uh, the part B of first internal examination of data science is completed, and in the later video, we will discuss about part C, data pre-processing for complaint analytics uh, in this internal examination. Uh, with this, thank you so much for watching.